So the rate of change of velocity delta v divided by delta t is called as the acceleration of the particle. The acceleration of the particle. Acceleration is defined as a rate of change of velocity. As we mentioned, for the case of velocity, the acceleration is also taken during an interval from t1 to t2. So this can be represented as an average acceleration. Hence, similar way to the definition of the instantaneous velocity, we can write instantaneous acceleration as a at t is equal to dv divided by dt, that is rate of change of velocity, the first differential of velocity. Or we can also write this one as d square r divided by dt square, d square r divided by dt square, as v is equal to delta dr divided by dt. So the acceleration can also be defined as a second differential of position vector, or this is the first differential of velocity vector. So we have seen what is the variation of the position with respect to the time, and how the quantities velocity and acceleration can be defined in terms of a time change. We can define velocity as a rate of change of position with respect to time, and acceleration as rate of change of velocity with respect to time. Till this moment, our input parameter mass was a silent quantity throughout our analysis or the processes. Now let us try to incorporate the mass into these quantities. I am incorporating the mass with velocity. Mass with velocity. That means we are now entering into the Newton's laws of motions, or I can say I am entering into the laws of motion of mechanics. So here I have drawn a column or a process column in order to define the quantity of motion, which is known as the linear momentum. And I'm going to incorporate the factor mass into the parameters. Like we all knows that the mass of a quantity or mass of a body directly defines the amount of inertia content of the object. The mass can be defined as the total amount of inertia content of an object. Likewise, I would like to define the linear momentum of an object as the total amount of motion content of the object. The total amount of motion content of the object, I am defining it as the linear momentum of the body. Linear momentum, it's a vector quantity. As we have shown in this flow chart, I am going to connect the mass with the velocity. Mass with the velocity. We will get the expression for momentum as P is equal to mass times velocity. So immediately I can define this is a vector quantity, and the SI unit of this quantity is kilogram meter per second, and the dimensional formula can be written as mLT raised to -1. This is the linear momentum of the object. Now we are into the Newton's laws of motion. Till this point we can say that we have seen the one-dimensional motional components, second two-dimensional motion components, and the